Welcome. In this video, I'm going to be explaining other forms of direct proportion. So from what we've covered so far, if y and x are variables and they are directly proportional to each other, that would mean that y over x is equal to a constant, or you could write it in the form of y equals to a constant times x, where this is the equation relating the variables y and x. And if you plotted a graph of y against x, it would be a straight line through the origin because they are directly proportional. Now, we are going to use this question to understand other forms of direct proportion. Now, the following table gives the mass y grams of a square plate of side x centimeters cut from an iron sheet. We have values of x and values of y. Now, if we plotted a graph of y against x, it would come out like this. If we plotted a graph of y against x, it would come out like this. You find that it is a curve. Now, because it's a curve, we interpret this as y is not directly proportional to x. If it were, it should be a straight line through the origin. But this is a curve, meaning that y is not directly proportional to x. Part B of the question was then plot a graph of y against x squared. This would mean that you'd have to transform the table so that it looks like this. You have values of x, values of x squared, and y, and you're plotting a graph of y against x squared. Now, the graph would turn out as a straight line. Now, because it's a straight line, we interpret this as y is directly proportional to x squared. What does that mean? The equation relating y and x squared would be y equals to a constant times x squared. Now, we do have other forms of direct proportionality such that one variable, for example, in this case where we have y, let's say y equals to 2x squared, okay? It means that y is directly proportional to x squared, not just x, but x squared, such that you can do y over x squared equals to 2, and 2 is a constant. Now, that is the other kinds of direct proportionality. Let me give another example. We could have variables p and q such that p equals to q plus 1. Okay, let me add there a 4. P equals to 4 into q plus 1. Now, p is not directly proportional to q because p over q, if you tried doing p divided by q, it wouldn't be a constant. Rather, if you did p divided by q plus 1, it would be a 4, which is a constant. Now, in this case, p is directly proportional to q plus 1, not just q. It's directly proportional to q plus 1. Why? Because p out of q plus 1 equals to 4. And if you plotted a graph of p divided by q plus 1, it would be a straight line through the origin. So what have we been talking about? We could have two variables, but when one, the proportionality, the direct proportionality this time is between a variable and an expression.